Hey, on this video we are going over question 14 from your study guide. In this question we have a giant alien throwing a ball straight into the air, initial velocity of 8 meters per second, takes the ball 10 seconds to land on the ground at a velocity of negative 12 meters per second, and you're going to use the graph to help you. So here we have a velocity time graph. Again, make sure you check what kind of graph you have. So you can see it starts at a positive 8, ends at a negative 8 meters per second velocity. It goes for 10 seconds. We don't know at what point it reaches its highest point, but we're going to solve for that. So first up for question A, we're looking to find the acceleration due to gravity on this alien's planet. So we have a velocity graph and we want to find acceleration. We are going to use the slope of the line. So we're going to do rise over run for that. Your rise, it goes from positive 8 down to negative 8, so it's total of negative 20 meters per second is the rise, divided by the time it goes for is 10 seconds, and that is going to simplify it when you divide negative 20 by 10 to negative 2 meters per second squared. Now for part B, we're looking for how long does it take the ball to reach its highest point. So we now know the slope of the line. The slope doesn't change here this entire time. So we can use that information to find when it's crossing the x-axis here. So we're going to just focus on this portion of the graph and use that slope formula. So we know our rise is going to be negative 8 for that portion because it's dropping from positive 8 down to 0. So that gives us negative 8. We don't know the time, so I'm just going to write this in as t since we don't know the time. And we know that slope is now negative 2 meters per second. So we know this has to work out. So you can multiply t over, that gives you negative 8 equals negative 2t, and then divide both sides by negative 2, and that is going to give you an answer of positive 4. So 4 seconds would be your time. So that's your answer for B. So then I'm going to add that information to my graph here, and that's going to be 4 seconds. Without doing all that math, you can, if you're good at just kind of examining things, you could kind of follow down the slope down the line and figure out exactly the intervals it would need to hit 4 here and then 10 here. But this is a lot easier for most people to do slope than rather kind of analyzing what's going on here. All right, for C, it's asking you to find the maximum height the ball reaches. So just to give you kind of a visual, this alien guy, which is going to be my stick man, he's throwing the ball up and then it's going to hit this highest point and then land lower on the ground. So we're looking for right here at the top. We're looking for this highest point that it reaches. And we're going to measure this off the ground because that's how you measure height, from the ground. So with what we have, what we want to use to do this is going to be to use the area for the last segment of the ground here. So this will tell us how high it's going to be, or rather, technically, it's telling us how far it's falling from here down to here. So for height, it's just going to be positive. So for this, you have a triangle, so it's going to be 1/2 times the width of that triangle is 6 seconds because it goes from 4 to 10. And then its height of that triangle is negative 12 meters per second. So when you multiply that out, you're going to get an answer of negative 36 meters. So technically the maximum height is 36 meters because we don't measure height in negative numbers, we measure it in positive numbers. All right, so now for D, we are looking to sketch the position time graph. And when I say sketch, I'm looking for those key numbers. So in this case for time, our key numbers are 4 seconds and 10 seconds. And then we know it's going to be launched. He's throwing it up higher than it's landing. So we know we're going to start from up here, and it's going to hit a higher point. So it's going to go up, hit that max height at 4 seconds, and then fall back down. We know when we throw things in the air, they slow down as we reach the highest point and speed back up as they go to the ground, which we also want to show. And that matches what we have going on in the velocity graph. We have it slowing down in the positive, speeding up in the negative. So we want that to match here, slowing down in the positive, speeding up in the negative. Now for the other key information, we want this y-axis labeled. We kind of already found some of our information. We know it's going to fall 36 meters from 4 to 6. So we know this highest point is going to be 36. So that's going to be this label right there. And then I want this lower. Where is it starting out from? And to figure this out, we are going to use the area for the first triangle. So we're looking right here. So to solve for that, you're just going to do 1/2 times its width of 4 seconds times its height of positive 8 meters per second. When you work that out, you get 16 meters. So it's going to start off at the difference between this highest point and this point needs to be 16. So if I subtract 36 minus 16, that would give me 20 meters. So it's going to start from a height of 20 meters. It's going to then travel 16 meters up into the air, hit that maximum height of 36, and then fall back to the ground, and it's going to fall negative 36, which matches the area we found for this part of the triangle that we got for part C. All right, so now we are on to the last part. Let me try and make some room here. We're just asked to sketch the velocity time graph, and this is pretty easy because we just have one diagonal line to work with. And it maintains the slope the whole time. So I'm going to just go ahead and label the 4 and 10 seconds like we had. But we found our slope earlier in part A. That was our acceleration. That's what we want to plot. And we found that to be negative 2 meters per second squared. So that's what our line is going to be on here. So it's just going to be a horizontal line for those 10 seconds at negative 2. So those are always an easy one to draw. But anyway, that's it for this set of questions. If you still need help, please let me know.